In this video, we're going to graph an exponential function and the inverse of the exponential function. When you guys see this notation here, where the -1 is an exponent, that is just notation for the inverse function. Let's go ahead and complete this first table. If we substitute this 2 for this x, that would be 3 squared, which is 9. If we substitute this 1 for the x for that same x, we would get 3 to the first, which is 3. If we substitute this 0 in for that same x, 3 to the 0, 3 to the exponent 0 is 1. If we substitute the -1 in for that x, we get 3 to the exponent -1, which is 1/3. And lastly, if we substitute this -2 in for that same exponent x, we get 1/9. One over 3 is about 0.33, and 1/9 is about 0.11. Let's go ahead and graph these 5 points on the graph. The first point is 2, 9. Go to the right 2 and up 9, which is right here. 1, 3, go to the right 1 and up 3, which is about right here. 0, 1 is about right here. -1, 0.33. 0.33 is going to be between 0 and 1. About right there. And -2.11 is going to be even closer to the x-axis, but not quite touching the x-axis. So if we drew a line through those points, we would get something like this. This problem is saying that a log base 3 of x is the inverse of 3 to the x, or f to the x, f of x. Which means that the inputs of 3 to the x should be the same as the outputs of a log base 3 to the x, and the outputs of 3 to the x should be the same as the inputs of log base 3 to the x, by definition of an inverse, where the x's and y's should be switched. So let's see if that is true. Let's take the outputs of f of x, which are 9, 3, 1, 1/3, and 1/9, and let's put them for the inputs for the inverse of f of x. So we'll put 9, 3, 1, 1/3, and 1/9. can use your calculator or what we learned before. Remember, for calculator work, you can go to Google GeoGebra and then click on the very top on the graphing calculator for GeoGebra, and you should be able to use your logarithm functionality. And you will get log base 3 of 9 is 2. Log base 3 of 3 is 1. Log base 3 of 1 is 0. Log base 3 of 1/3 is -1. And log base 3 of 1/9 is -2. So notice how the numbers in this column, 2, 1, 0, -1, and -2, are the same numbers as the numbers in that column, 2, 1, 0, -1, -2. So the inputs of f of x match the outputs of f inverse of x, and the outputs of f of x match the inputs of the inverse of f of x. And let's plot these points. So we'll get 9, 2 is about right here. 3, 1. 1, 0. 1/3 -1. And 1/9 -2. It's getting closer and closer to that y-axis this time, but it's not quite reaching the y-axis, and let's quite touching the y-axis, and let's draw a curve through those points. Another way you can tell or show that this is the inverse of each other is you can always, if you draw the line y equals x, the blue graph and the red graph are symmetric about this line y equals x. Y equals x just means that every point on that green dashed line, right, that's the point 5, 5. Right, this is the point 9, 9. So, right, so every point y equals x, 5, 5, 9, 9. The red graph and the blue graph are symmetric about that graph, that line. I'll complete the table of values for the tables on the left for g of x and the inverse of g of x, and I'll have you guys do the ones on the right hand side. So if we put 2 for this x, we get 7 squared is 49. And if we keep going down, 7 to the first is 7. 7 to the exponent 0 is 1. 7 to the exponent -1 is 1/7. And 7 to the exponent -2 is 1/49. For the inverse of g of x, it's going to be log base is 7 here, so our base is 7 of x. For the inverse of g of x, it's going to be log base 7 of x. And we're going to switch the inputs and the outputs. So it's going to be 49, 7, 1, 1/7, and 1 over 49. Log base 7 of 49 is 2. Log base 7 of 7 is 1. Log base 7 of 1 is 0. Log base 7 of 1/7 is -1. And log base 7 of 1 over 49 is -2. Go ahead and try and fill in these two tables of values.